Okay, we got to access modifiers. Earlier in this course, you learned about access modifiers. You learned about public and private. In this lecture, I'm going to explain access modifiers in more detail. I'm going to talk about why access modifiers are important. And to explain that, I'm going to use the black box metaphor. And finally, we get into C# access modifiers. So let's get started. A metaphor often used in object-oriented programming is black box. Look at this black box image here. We don't know what's inside this box. There is limited visibility. And there is just one, I don't know if it's a button or a light, and that's all we can see. We want to design our objects to look like a black box. So there is limited visibility from the outside, but there could be a lot of magic going on inside. Now you might wonder, why do we want to design our classes like a black box? It all comes back to isolating changes. The more a class reveals about its internals or its implementation, the more risky it becomes when we are going to change that class, because there could be other parts of the system that rely on that implementation. So we want to limit the visibility from the outside and make our class look like a black box. Here's another metaphor. Look at this DVD player. All we see from the outside is just a few buttons and an indicator. But there's a lot of complexity inside that DVD player. There's an electronic board with a lot of ICs, and who knows, there's a lot of complexity there. What we see from the outside is called public interface. Again, we want to design our class to look like this DVD player. So its public interface should be very simple. Now, in C# we use access modifiers to control visibility to members of a class. You have already seen public and private. But we also have protected internal and protected internal. Let's explore these access modifiers in detail. A member that is declared with public is accessible from everywhere. So in this example, we have a customer class with a promote method that is declared as public. With that, we can create a customer object somewhere else in the code and call the promote method. The promote method is going to be visible to the outside. That's perfectly fine because promote should be part of public interface of the customer class. It's not about implementation. We may want to promote a customer, and that's an expected functionality. Now, private is the complete opposite of public. So a member that is declared as private is only accessible from that class. In this example, in our customer object, I have a method called calculate rating. We're going to use this method as part of promoting. So perhaps we need to do some calculation, and based on the result of that, we may promote a customer to a certain level. This is about implementation detail. It's about the internals of the customer class, how we promote a customer. We don't want other classes to know anything about that. So that's an example where we can use the private modifier to limit access to this method. So as you see in the example, if we create a customer object, we are not going to be able to call the calculate rating method. It's not going to be compiled. Okay, next is protected. A member declared as protected is accessible only from the class and its derived classes. What does it mean? Well, look at our calculate rating method again here. This time I declared it as protected instead of private. So this statement says accessible only from the class and its derived classes, which means outside this class, if you have a customer object, we are not going to be able to call this method. So it's a little bit similar to private. The difference is if we derive a class from customer, let's call it gold customer. That method is going to be visible in a derived class. Now there is a problem here. The problem is, as we explained in the last slide, calculate rating is about the implementation detail, which should be encapsulated inside the customer class itself. We don't want anywhere else in the code we know about this method, because we may change it in the future. We may rename it, we may change its parameters, or we may even remove it. We don't want anywhere else in the code base any dependency to this method. Now the problem with the protected modifier is any classes derived from this class will still be able to see this method. And that breaks encapsulation. Because as I've explained throughout this course, encapsulation is about hiding the details inside a class and only revealing the minimal. That is the public interface of a class. So a lot of developers consider protected a bad design in the C# language. Having said that, you will see a lot of places in the .NET framework or in many other libraries where protected is used. Now, to make all this easier for you, what I'm suggesting is avoid it if you can and prefer to use private methods. But if there are circumstances that you have to use protected and you have a valid reason for that, that's okay, go ahead and use it. Just be aware that you're revealing the implementation detail of a class to any of its subclasses, which can be trouble in the future. Okay, next one is internal. Internal is a modifier that we often use with the classes, not their members. It really doesn't make sense to declare a class member as internal. But there are cases that you may declare a class as internal. For example, continuing from our last example, imagine we have a separate class called rateCalculator. And rateCalculator might have a bunch of methods and some complex logic to calculate the rate for a customer. Now, this class is part of the implementation detail for the domain of customers. So, inside that domain, it's okay for every other class to see this class. But outside that domain, we don't want anyone else to know about the existence of this class. So how we implement that in C# terms is we create a separate class library, and in that class library, we declare the rateCalculator class as internal. So inside that assembly or that class library, everywhere we will see this class. But outside that assembly, no one knows about this class. Again, I'm going to show you all of this stuff in the code. So if that sounds unfamiliar, don't worry about it. And finally, we've got protected internal, which I would say is the most weird thing in C# language. Basically, what it means is a member declared as protected internal is accessible only from the same assembly, and that's because of the internal, or any derived classes, and that's the result of protected. So here is an example. We have a customer class, and it has a method called weirdo that is declared as protected internal. Now, this is really bad, both in terms of teaching, learning, writing code, and someone reading that code. It takes a lot of brain power to understand what's going on. I just added that in this lecture because I want my course to be comprehensive, but it's very unlikely that you're ever going to need it. Okay, let's start coding and see all these access modifiers in action. Okay, let's start by creating a customer class. So public class customer. We can define a couple of properties like ID and name, and a method like promote. Now let's go to the main method and create a new instance of customer. So var customer equals new customer. Now if we type customer dot, here is the public interface of this customer class. So we have a few methods like equals, get hashcode, get type, and toString, which are derived from the base object class. And we also have these bold members here that are defined in the customer class itself. So ID and name properties and the promote method. All of this together make up the public interface of the customer class. Now back to the black box metaphor or the DVD player, we want to minimize this public interface. The more we reveal about a class and its members, the more we risk that other parts of the code will be dependent on those members. So this creates more coupling, which means if we are going to change the implementation of our customer class, other parts of the code may get broken. Let me show you how this happens. So I'm just going to remove this. Let's create another method. We're going to calculate the rating of a customer. So just public int calculate rating. I'm going to leave out the implementation of business logic here and just return a simple number because we don't want to get distracted with some business rules and whatnot. What I want to show you is in the promote method, perhaps there is a call to this calculate rating. So we can say var rating equals calculate rating. And then based on what is returned from that method, we can make decisions. For example, if rating is whatever, then console.writeLine promoted to level 1, otherwise promoted to level 2. Just keeping it simple. Now the problem here is this method is about implementation detail of the customer class. from the outside, we don't really need to see this method. What the consumers of this customer class need to see is just this couple of properties here and the promote method. How the promote method does its job, which in this case means calling the calculate rating, is no one's business. So this is what encapsulation means. We're just going to hide the details inside and reveal the public interface. Now the problem happens if somewhere else in the code, we, out of interest or curiosity, have a call to calculate rating method. Now, because this is the implementation detail of the customer class, tomorrow we may decide to change it. For example, we may decide to pass a parameter like a switch, say, exclude orders. It might have some meaning in the business domain we are working on. So we're changing this method, and what happens is, see, we get this red underline here. Now, if this method is being used outside this class, like in this case in our main method, here the code is going to break. And imagine if there were 10 other places in the code where we made a call to this method. But in this case, if this method was declared as private in the first place, nowhere else we had a call to this method. And fixing that change would be as simple as just making a change in one place in the code, which is the promote method that is using this calculate rating method. So here I would say exclude orders true. But this is the reason we want to minimize the public interface of a class to the outside world. Now let's get rid of this calculate rating method here. Okay, now let's put this customer class in a separate file to clean up our code. So Alt and Enter, Enter. Now back to program. Let's create a class that derives from the customer class. So maybe call it gold customer. And add the customer here. Okay, here we can have a method like offer voucher. So let's say we're going to give a voucher to our gold customers. So public void offer voucher. And of course, this method needs some argument like a voucher object. But again, to keep things simple, let's not worry about the parameter. What I want to show you is inside this method, if we use this dot, see, these are the members that we see in this class. So equals, get hashcode, get type, member-wise clone, and toString were derived from the base object class, that is the parent of every class in .NET. ID, name, and promote are derived from the customer class itself, and offer voucher, which is indicated by bold, is declared in this class itself. So as you see, calculate rating method is not visible here because we declared it as private. So back to customer class. Look, calculate rating is declared as private. And my rationale was because this is the implementation detail, we want to encapsulate it. We don't want anywhere else in the code to have dependency to this method. Now, if we change this to protected and go back to our gold customer class, look, this dot, and here we see the calculate rating method. And here's the problem. We created a dependency to the implementation detail of the customer class. So again, if tomorrow we are going to change that method, maybe we rename it, maybe we add a parameter, or maybe we even delete that method, gold customer class is going to be affected. Let me show you this in action. So imagine as part of offering voucher, we're going to call this method and let's pass whatever switch here. And we get a rating here. And based on that rating, we're going to do some logic. Now, if tomorrow we go to the customer class and decide to totally drop this method, maybe our business logic for promoting a customer is changed. So I'm just going to remove this method. And let's say I'm going to change the logic of promote method, promote logic changed. Now, see what happens in the gold customer class. So the calculate rating method does not exist anymore because we deleted it from the parent. Again, here is where encapsulation is broken. So try to avoid protected unless you have a valid reason to use it. For example, if you know that the concept of calculate rating is completely stable in the business domain you have been working on, maybe it's okay to use that. Also, as I said, there are some design patterns that use protected methods as part of their implementation. Okay, let's move on and see the internal modifier. So I'm going to just remove this class. Okay, to see the internal in action, we need to move our customer class to a separate assembly. So what I'm going to do is right-click on the solution, go to add. Actually, you're not going to see that in the screencast, so I just drag and drop the solution explorer to the left. So you can see, right-click on the solution, add, new project, and we select class library. So with a class library, we create a DLL, or dynamically linked library. And we can reference that in various applications. So give it a name. Let's say we are building an application for Amazon. So I'm going to call this class library Amazon. Now by default, we have class 1 in this project, this class library. I'm going to remove that. And then I move this customer class inside the Amazon class library. Yes. When we open it, note that here we have the old namespace. So we need to change that because now the customer class is inside the Amazon project. So with ReSharper, this is pretty easy. You just put the cursor here and Alt and Enter. The first item says, move declarations to namespace Amazon. Enter, done. So here in this project, we're going to implement all our business logic. We have the customer class, and we're also going to create a new class for calculating rating of a customer. So public class rate calculator, and it could have a bunch of methods and properties and fields. I'm just going to keep it simple. So let's have a method called calculate, which gets a customer object. And for simplicity, let's just return 0. In the promote method of our customer, I'm going to make a call to this calculator. So var calculator equals new calculator, new rate calculator, and rating equals calculator.calculate. And I pass this as the object, as the customer object to that method. And based on that rating, we can do some conditional statements and decide how to promote the customer. I need to add a caveat here. Generally speaking, it's not a good practice to instantiate a new object like the rate calculator inside a method here, because this creates coupling or dependency to this object. When we get to the section about interfaces, I will show you a better way to implement this code. For now, let's just move on. So let's recap. First of all, I'm going to put this class in a separate file. So Alt and Enter again. All right, let's recap. We have the Amazon class library, which is going to be our DLL, with two classes, customer and rate calculator. Rate calculator simply has a calculate method and returns 0. In the customer class, as part of promoting, we use the calculator object to calculate the rating. Now, let's clean this up. Back to our program. Here we have the customer object, right? I just noticed a problem here that when we drag and dropped the customer object from AccessModifiers project inside Amazon, it was not deleted from the source. I think I made a mistake while recording. So I'm just going to delete this class. All right, now in our program, which is in the AccessModifiers, see, customer is not detected. So we put the cursor here, and ReSharper has this red icon here. If we press Alt and Enter, we can activate that. So it's suggesting to reference Amazon. What it does is it goes to the references folder and adds a reference to Amazon. If you don't have ReSharper, what you need to do is, let's delete that. And delete the using statement on the top. So see, the customer class is not detected. You simply right click on references, add a reference, then expand solution. See, in our solution, we have another project called Amazon. I select that and click OK. So now we have a reference to that assembly, to that class library, and we can use any of its classes. And now, to use the customer, we simply go on the top, type using Amazon, because that's the namespace. So you see, with ReSharper, it's much easier. You don't have to do all these manual steps. All right, let's move on. Now, let me show you that in the main method here, if we type Amazon, which is the namespace, dot, we see two classes, customer and rate calculator. In this case, rate calculator is used as part of promoting a customer. So we can argue that it's the internals of the customer or the Amazon domain. And based on the encapsulation principle of object-oriented programming, we shouldn't reveal the implementation anywhere in the code. So the problem is, if we use this rate calculator here, calculator. Now this project, our AccessModifiers, this program class in the main method, we have a dependency to this calculator object. In the future, if we go to our Amazon class library and decide to get rid of this rate calculator, let's remove this class here. The areas that are affected, one is inside the customer class here, but we also have this line in somewhere else in the code that is broken. And that is not good, because this way we could have 10 other places in the code where there is a dependency, the rate calculator, which is about implementation. If we declared this rate calculator as internal, it would have been visible inside this class library here, but not anywhere else in the code. So let me add that rate calculator back here. So I add a new class, rate calculator, and put that calculator method back, calculate, return 0. Now this time I declare it as internal. What happens is, in the customer class, this class is visible because it's part of the same assembly. But after this assembly, when we go to AccessModifiers, we cannot access this class. With the red underline, it says cannot access internal class rate calculator here. Well, that's pretty much for this lecture. I hope you enjoyed it, and thank you for watching.